So here we'll discuss one questions which was appeared in 2019. The question number is 26. So this this was the questions. So in these questions, a particle of mass m is confined within a infinite potential well, and you have raised slowly a thin wall at the middle of this infinite potential well to the infinity. That means the height of this thin wall is infinity. Then you have to find out, actually you raise this wall in such a way that the system remain in the ground state. The system remain in the ground state, and then you have to find out, so how much work is done to separate this box into two compartments by raising this infinite wall. Okay, that means we can see in again that you have a infinite potential well which wall at as minus L plus L, the center is at 0, and you raise a very thin potential wall which is height is at infinity, so that it can divide this infinite potential well into two compartments. Let it be compartment 1A and the compartment B. Then you have to find out how much work you have to done to do this. So and we know that means, so we know that from the work energy principle, from the work energy theorem, that the work done is nothing but the change in kinetic energy. Change in kinetic energy. So here you know that in this the potential is set at 0. Here also the potential is inside this box is 0. So that means the total energy is actually the kinetic energy. Here also the total energy is the kinetic energy. That means you have to find out the change in kinetic energy. That means the change in total energy. Then you have to find the total energy of this system and also the total energy of this system. Then we have to make a difference between these two total energy, and you can find the work done. But here the question is that suppose when there is no separation, the particle is confined within this box. That is the probability of the particle to find everywhere in this box, from starting from this point to this point, minus L to plus L. But now when you raise a infinite wall at the middle of this infinite potential box, that means particle can either in this compartment A or in the compartment of B. Simultaneously particle cannot stay at both this compartment, because if the infinite potential height is infinite, that means there is no probability of tunneling from the electron particle from this compartment to this compartment. So that means either you can find the particle in this compartment or you can find in this compartment. That's why you have to, your system becomes either this one or this one, which will start from minus L to 0 or 0 to L. That means you have to find out the energy difference between this system or these systems. Let me take this system. Okay, the length is equal, so there is no problem in both these systems, this system and this system. So energy of this system, the ground state, so energy will be pi square h square by 2m. Length is 2l, so it will be 2l square. So energy of the system will be pi square h square by 8m l square, and energy of this system will be pi square h square by 2m l square. Now the difference between these two things, let it be, give it E1, let it be E2. So E2 minus E1 will be 1 by 2 minus 1 by 8 whole multiplied over m into L square. So this will be 4 minus 1 by 8 pi square h square by m L square, and this is nothing but 3 by 8 pi square h square by ml square. Now this is the energy difference, and which is obviously the work done on the system to separate into two bucks. Now go to the option. We can see that the first option is the 3 by 8 pi square by L square. So correct one is the first option.